so first example we have is this one. We want to verify that the left side is equal to the right side. And we have to pick which of these sides we're going to do the work on. Should we try to simplify this to make it equal to the right, or should we work on the right to try to make it equal to the left? And there are some opinion questions on this one. Which side should we work on? I would say normally there's not like a right answer. Like you could work on either one of them and it would be okay. My suggestion is work on the side that looks more confusing to you. You're saying like, why would I work on the confusing side? Because if it's the confusing side, then you know some things you can do to it to try to make it look as simple as the other side. So in this one, we have secant times cosecant. And on the right, we have tangent plus cotangent. So my thought process on this one is to work on the right side. And the reason for that is because it's two trig functions added together. They're separate right now, as opposed to on the left, where they're just already multiplied by each other. So what we're going to do is do some trig, do some algebra to make this right side equal to the left side. And this is one of the 90% problems. Step one, get everything in terms of sine and cosine. So you have two fractions. These two fractions are trying to add with each other. The plus sign means they're trying to add them. In order to add fractions, you need a common denominator. Do you know what that common denominator is? What does this first denominator need? So let's multiply the denominator by sine of x. And if you multiply the numerator by sine of x, what does that become? Sine squared x. What does the second denominator need? Cosine x. And if you multiply the denominator by cosine of x, multiply the numerator by cosine of x, what does it make the numerator become? Cosine squared. So there is step one. Now they have the same denominator, which means we can add them together. When you add them together, you keep that common denominator. And you add together the numerators. When you start doing enough of these, you recognize some of the familiar patterns, specifically in that numerator. What is that numerator really? What's sine squared plus cosine squared? 1. So it's 1 over cosine of x times the sine of x. Unlike the simplifying problems that we did in section 5.1, I know what I should end up with. This right side, when I'm done, should be equal to that. So I'm going to glance back over at the left. I'm trying to make it equal to this. This is what we currently have. Can you make this look like secant times cosecant? Well, I know I could split this. I could call it 1 over cosine times 1 over sine, right? 1 over cosine times 1 over sine. And what is 1 over cosine? What's 1 over sine? Which is what we're trying to get. So I put a little check mark there, say it's verified. So again, a lot like what we did in the previous section. It should seem like a familiar process. But again, now we know where we're supposed to end up at. When you're done, one side should be equal to the other side. That's verifying trig identities. Sine squared plus cosine squared equals 1. I tan in seconds. I cotan in coseconds. And variations of those, as well as using good algebra skills. Now, I'm going to skip this one for now, so don't scribble this one down. Skip that one. We'll come back to it. Let's go to this one. I think someone asked about a similar problem to this one today. We had a simplified problem yesterday. This is kind of like that because we have to the 4th power. And to start these problems again, what you should be asking yourself is, well, which one of these sides looks more confusing? Which one of these sides looks like there's more work that I can do on it? So I'm going to have you turn to your neighbor real quickly, say hello, and then answer. The left or the right? Which of these sides looks more confusing, like there's more stuff that I could do to it? Go ahead.
Everyone's saying left. The right looks more confusing, but the left you can do more. But after you fracture the side, I said which wouldn't do more. The left one looks more confusing, or the right looks more confusing. Either one. Yeah, I know the left one.
Okay, here we go. So some of the comments I'm hearing, a lot of people are saying, I'm going to work on the left. It's not that it looks more confusing maybe, but it looks like there's more stuff I can do with it. What I would say why the left looks maybe confusing isn't the word. Maybe it's more jumbled up. What I would say the left has more like jumbling up on it is we have two trig functions. We have a cosine and we have a sine. They're both to the fourth power, as opposed to the right. There's only one trig function and it's only squared. So I would work on the left. And after seeing some of these, you start to get an idea of how you can start them. Do you know what your first step is? Factor it. And after that, we put a little equal sign. I'm not going to keep writing the right side of this every time. That's just wasted writing. Just the left side equals. The left side equals until I show that it's equal to the right. So there's my first step. Capital A is the angle. Sometimes we use a lowercase x. Sometimes we use the Greek letter theta. In this case, it's just angle A. In this blue equation, what can we drop off? First part or second part? First part, because what is cosine squared plus sine squared? 1. So we have cosine squared of A minus sine squared of A. Now the left side, what's in green, looks a little bit more like the right side. I'm going to glance over at the right side and say, okay, on the right, the only trig function that's over there is the sine squared. On the left, we have both of them. So how about we make a little substitution here? If I know that sine squared plus cosine squared equals 1, then what does cosine squared equal? 1 minus sine squared. So let's take this out and call it 1 minus sine squared minus the other sine squared that's there, and see where this leads us. One minus sine squared minus sine squared. Isn't that 1 minus 2 sine squared of A, which is what the right side is equal to, so verified. So we start with this one, skip, did this one, oops, did this one. I'm going to skip another one. Come back to it later. So if you wrote it down, you'll get to it later. Let's go to this one. Notice I left a lot of space for this one. I don't exactly know why. I know we make it could take a lot of space. Left side, right side, we have to pick what to work on. I'm going to have you turn to your friend again and give your opinion. Which side do you think we should work on, the left side or the right side?
Right. Yeah. Sure. Right. I don't know. Left looks kind of like I want it more, but that's true.
Okay, you had your time to talk, and lots of good ideas. Well, on the left side this, the right side that. You could pick either side, so don't just think, well, the teacher chose the right, I was going to do the left, I must have done something wrong. No, just I'm going to choose to do the right. Because instead of just trig minus trig, it's 1 over, there's a fraction already of trig plus trig. So I'm going to work on the right. 90% of the time I said get everything in terms of sine and cosine, right? This is part of the 10%. Why do you think I'm not going to get it in terms of sine and cosine this time? It's because I recognize something. Anybody else recognize something here that looks a little bit familiar? Sine squared plus cosine squared equals 1. I tan in seconds. I cotan in coseconds. which means that 1 is equal to cosecant squared minus cotangent squared. Do you almost see that on the right-hand side? Do you see the start of that? If not, let me go a little bit further with this. 1 equals, couldn't you factor this? Isn't it a difference of squares? So wouldn't it be cosecant minus cotangent, cosecant plus cotangent? And this is all work off to the side. Why did I decide to do this? Because I looked in this denominator and I said, that seems kind of familiar. I know cotangent and cosecant have this relationship with each other. So I wrote it down. I saw this, which is almost the same as the yellow. Factor the right side, it looks like this. Here is what was originally on the right-hand side. I want you to talk to your friend. What do you think you're going to do to this right-hand side to make use of this idea over here, this Pythagorean identity?
Just going down a rabbit hole, and then once you multiply that, maybe. I don't know. Okay, it was a guess. You might be right. I can't picture.
All right, I got some good feedback by listening to you guys. Some of the things I heard, could you just multiply this like on the right to get it off the right to bring it to the left? Good idea, but when we're doing these verifications, you can't actually do that. You can only work on the right or only work on the left. If you wanted to work on one side so you can work backwards a little bit, that would be fine, but I can't just get rid of this right-hand side. Good idea, but that's not one of the things we're allowed to do. So good ideas, but we just can't do that. Trying to match up with this. What do you think we're going to multiply the numerator and denominator both by? Cosecant minus cotangent. Cosecant minus cotangent. Multiply them both by that. And what does that accomplish for us? Well, the denominator would become cosecant squared minus cotangent squared. The numerator would be cosecant minus cotangent. This is a big breakthrough. Look at that denominator. It's equal to 1. So the denominator is equal to 1. We get this, which is what we were trying to have it equal. So this one is verified. Going back to the very beginning, I said 90% of the time you're going to write these in terms of sine and cosine. We didn't on this one, although you could have. You could have written everything in terms of sine and cosine, gone through the problem, and you probably would have taken up a lot more space, which is totally okay. There's no like extra credit for writing it the shortest or the longest, but I prefer to write as little as I can. That's why I use this Pythagorean identity to help shorten up the problem a little bit, and now it's verified. So the more of these you see, the more of those little shortcuts and like little tricks to the puzzles you'll find. I'll reiterate it again. If you're finding like this is like really hard, I'm really struggling, you're probably in the majority. That's why we're taking so many days on this. If you're finding like these are simple, I'm picking it up very quickly, then I guarantee you you're ahead of the curve right now. Great, good job. But most of us are probably somewhere like, this is still really confusing for me. Let's go to here. Give you a moment to take a look at it again and ask yourself some of those same questions, which leads to which side of the equation do we want to work on? Do I want to work on the left or do I want to work on the right? To me, sometimes there's a clear winner. I'm definitely going to choose the left, or I'm definitely going to choose the right. Other times like this one, it's a total toss-up. They both kind of look like messes, don't they? On the left, you only have two trig functions. They're multiplied by each other, which is great, but you have a sine cubed and you have a cosine to the fourth. Not exactly pleasant. On the right, you have cosine in two different places, and the cosine is all the way to the sixth power, and it's still multiplied by sine. That looks like a mess to me also. They both look like, seriously, like they've got a lot going on with them. I don't think there's an obvious choice. Blake, pick a side, left or right? Let's work on the right then. So the right side is where we're going to do our work. Try to make it look like the left. How are we going to do this? Well, I'm going to take a peek over there on the left and see there's supposed to be a sine cubed. We only have a sine to the first. And then there's supposed to be a cosine to the fourth. And I see all of this. So I'm comparing that with where I see the cosines. Does that give you an idea? Like, what can we do with this to get just a cosine to the fourth x all by itself? Factor out a cosine to the fourth. Factor it out. It goes into both of those terms. Factor it out of both of them. I know it needs to be all by itself. Now it's all by itself. What's going to go inside of these parentheses? Minus cosine squared. What about in front of it? A 1. Still times this sine of x at the very end. So step 1, factor out the cosine to the fourth of x. How did you know to do that? Because there was a cosine to the fourth of x on the left, and now these two things are matching up with each other. The stuff that's left, sine cubed, and that. Can you make these two underlined red things be equal to each other? What's 1 minus cosine squared? Times the sine of x that's at the end. Oh, we're almost there, right? Let's change the order up. What's sine squared times sine? Times the cosine to the fourth of x. Verified.
Do we have to write it in the same order?
Question, do we have to write it in the same order? Probably a good idea. If you didn't, it's just going to make my job correcting a little less pleasant, and then I'll be a little angry when I'm grading yours specifically, Delia. And no, just kidding. Try to write it in the same order, though. Did this one look intimidating at the beginning? Did it look like, and then it turned out to be, not so bad? I don't know. We're all at different places. I want you to try this one. I'm going to be quiet for a bit. Try this one.
I'm telling you, I'm ahead of curve. You very much are. You just multiply it by yeah. Because Bob knew that I was like, I want to be that nice. I had my 4-0 today. Like, favorite. You guys did? Huh? Oh, I got it. I want to make sure you got it. Make sure you're ahead of the curve.
Yeah, I don't think you got it. You're all fine.
You want to see? Okay, I'll send it over to you.
Keep accent.
I'm good. I guess it's wrong.
I did. Zach says he can do it, so can you?
I mean, I think you should. I don't think that's necessary. I think I did it right. That's right, no? 9 equals 1.
Like your logic is right, but what you wrote down isn't quite showing up. I can tell, like, you have the right idea, it just wasn't.
Okay, I can show them more work, but I mean, about total class, the IQ would be at 40. So he'd be a great teacher. I'll be a great teacher. Anything about math. You'll be like one of those gym teachers. That's the only thing. I was confident for once, and now I'm back below the curve.
How many of you got it in terms of sine and cosine? Because you can. How many of you kept it in terms of this? Maybe because you realize that I tan in seconds, which means that 1 equals secant squared minus tangent squared, which is almost what you have in the denominator right now, right? So what would you multiply the numerator and denominator both by right here?
A positive.
The positive version of it? And then when you do this, the numerator is secant plus tangent over secant squared x minus tangent squared x. What does this denominator equal? Awesome, it's 1. So it's secant x plus tangent x equals check mark. Now these problems, again, they can be a little confusing at times. This should have seemed similar to one we did earlier with cosecant and cotangent, I think. But you know what the answer is supposed to come out to. So don't like say, and people inevitably like do different variations of this. Here's the original problem. And I said secant x plus tangent x equals verified, done. I'm not trying to pick on anyone in particular, but like you have to make sure you're showing the work. Like I didn't show nearly enough work to verify that, right? So make sure you're showing the steps. Part of like the confusing thing, like how much do I need to show? And that can be a little bit confusing at times. Like if you're seeing that there's a sine squared plus a cosine squared something, and you don't write sine squared plus cosine squared, you just write 1 instead. I mean, they kind of understand that, but try to make sure you're showing enough so it's clear that you're not skipping over a bunch of steps. I've talked to I remember my experiences when I was in college, even though it was a long time ago, and I've talked with former students who it's not uncommon to be in a math class in college where the professor's doing something, and he'll say, all right, through some basic algebra skills, you go from here to there. And the basic algebra skills might be something that takes up an entire sheet of paper. So like, is it really basic algebra skills? But they expect you to be able to fill in all those blanks. Well, this is filling in the blanks. These are those algebra skills that you need to make sure that you have. So don't just do what I did right here. Make sure you have all that.
I'm just setting an example for you guys.
So if you were Zach, you say done. Boom. Now this one, the right side and the left side. The right side is factored. I could try to multiply that out, see if I make it equal to the left. But somehow I have to turn the right side that has a cosine in it into a cosine and a tangent, and then another plus cosine somewhere, which to me seems like I'd have to take something that's kind of simplified on the right and really try to muddy it up to make it look like the left. So I would probably work with the left. And you look at the left, you say, oh my gosh, there's so much stuff over there, it just looks ridiculous. Remember, the strategy 90% of the time is to get things in terms of sine and cosine. That will start clearing some of these things up for you. So I would, again, recommend work on the left side. It's a lot more cluttered over there. Get everything in terms of sine and cosine because there's not a clear I tan in seconds or sine squared plus cosine squared equals 1. There's none of that clear stuff. So get it in terms of sine and cosine and then see how that starts to simplify things out. I'm going to give you a pause, give you a chance to see what you can do with this. Work on that left side. Eventually try and make it to the right side.
Could I show them the work?
I would want to see that this is secant squared minus tangent squared down there before you call it. Believe it or not, things actually even less than.
Okay.
Actually, that's
I put
that's
the
about what
secant
Zach-
squared and tan squared.
It's about what Zach showed, so if you're in that category, just keep on going.
Hey, I'm out this one. Like I said, same
I think this is every class, kind of fun.
kind of maybe.
You're
Depends on the
kind of
class.
funny. Just kind of. You're not funny. You're kind
Just
of.
kind of.
Can I make a Pete Davidson type deal? I don't like that game. It was started decent. No, just kidding. Yeah, no, I'm just here. Oh, time out. That's kind of take out two for my but like where you get just use from that side. You can't. There's no two. Yeah. And there's wall. Exactly. No, not this one. You know what to do after this? See, I was gonna subtract them both, but now you're gonna.
All right, did a lot of you get this as your first step? You wrote it out in terms of sine and cosine. Then you said, all right, those are going to cross each other off. So then it's 2 minus sine squared plus 2 cosine. And then you feel like, okay, I'm kind of stuck. Well, look on the right-hand side. What is the only trig function on the right-hand side? On the left, though, we have a sine and we have a cosine. Don't we want to swap this out and call it something different? 2 minus. What can we call that sine squared? So if sine squared plus cosine squared equals 1, what does sine squared equal? So this became this. Why? Because on the right, it's only in terms of cosine. So on the left, we want it only in terms of cosine. MD?
What if you factor out a 2 and then got 1 minus sine? Because then it would be cosine squared.
So if you factored a 2 out of both of those terms, you'd have 2 parentheses, 1 plus cosine of x, which is looking kind of like that. But then trying to bring the sine squared into the equation starts to make it a little bit more difficult, I think. So I would hold off on that part for now. Try to get it like before you don't want to really start factoring until you have everything all laid out and then bring it all back together. Any questions up through the red step? Let's distribute this minus sign. So it's 2 minus 1 plus cosine squared of x plus 2 cosine of x. Things should start clearing up a little bit. I'm going to change the order and put the cosine squared first. Oops, plus 2 cosine of x. And then what comes at the very end? Plus 1. Does that equal the right-hand side? It doesn't quite look the same. What do you think that the left-hand, we're going to have to do to the left-hand side? Probably factor it. And watch this. If you're saying, like, I don't know how to factor that, are you kidding me? Like that, like I'm supposed to factor this. What if over here I said, all right, what does cosine of x plus 1 times cosine of x plus 1? If we actually multiplied all this out, what would it give us? What's cosine times cosine? What's 1 times cosine and cosine times 1? 2 cosine of x. And then what is 1 times 1? 1. So it is factoring as cosine of x plus 1 squared, which is what it's supposed to be. So if you're thinking, I'm pretty sure I need to factor it, you can just check it like that. I didn't work on the right-hand side. I just saw like kind of working backwards. Like, what would this multiply out to? Oh, it multiplies out to that. Great. So that's how that's going to factor then. Let me back this up. All right, all stars. Here we are. Is there a clear and obvious choice for which side to work on? No. Is there a sine squared plus cosine squared equals 1? No. Is there I tan in seconds? Is there I cotan in coseconds? No. So what's going to be the strategy to get this one started? Sine and cosine. Just to keep everybody in the class working on the same page, CC, pick a side. The right side it is. So on the right side, get everything in terms of sine and cosine. Sometimes, like as a teacher, I can look at a problem and do like 3 or 4, maybe 5 or 6 steps in my head. I can see how it's going to turn out because I've done similar ones. Not because I'm smarter than you, but just because I've spent some time on the problems.
Wait. Okay.
I've just spent some time in the problems. I mean, that's fair. I mean, there's very good math people in here, and you just haven't had as much studying time as I have over 20 some years of teaching, right? Plus being a student myself.
Okay, but how do you get
Other times, there's problems like this that I can't see 5 steps down the road. I can't see 3 steps down. I'm just thinking I'm in survival mode right now. I know some of my strategies are get it in terms of sine and cosine. And then I'm thinking this looks so disgusting. I can either wave the white flag
Yes.
or
You can wait till I thought you just get 5 points off.
Put the check mark in.
But you did
Put the
that.
check mark in. Yeah. Your answer. Put the check mark
be Zach can be done. No. Or like, how about I try to I don't like the fact that there's fraction plus fraction over fraction minus 1. I don't like all these words, fraction. What could I multiply in the denominator to start getting rid of at least of some of these fractions?
I'm just a thought. I think some of the fractions are wrong. Like a lot of them, actually. Like actually all of them.
I do have a few off, don't I?
Top part 2.
One side of the cosine.
You just have a.
Woo.
That's how I want to test. I'm not good for this. That's how I perform.
He said I practice a lot.
Oh, I was just making sure you guys were paying attention. Is that
Put it on the wall.
is that one of the worst teacher lines? Like when you make some obvious mistakes that you totally didn't mean to make, and you say, "Oh, glad you guys are paying attention." Like, is that obvious?
Yeah. Only math teachers do it.
I had a huge wall poster back there, but nobody was adding to it, so I took it off, and now it's already full of more students. So yeah, that was pretty bad. I mean, that was really bad. I don't know what I was writing. Yeah, I don't really know what I was writing there. Okay. What can you multiply numerator and denominator by here? We're trying to wipe out some of these denominators and these fractions. So what could you multiply? Let's deal with down here first. What could you multiply by down here to get rid of at least some of this fraction stuff? Sine x, sine y. How do you run a marathon? One step at a time. How do you finish a problem? Sometimes just one step at a time. So times this, times this. What does this accomplish for us? All right, in the denominator, doesn't that give us cosine x, cosine y minus sine x times sine of y? Isn't that the new denominator? So I distributed it, and that's how I got this stuff at the end. So that denominator, in my opinion, looks a heck of a lot better than it just did look. Now go up to the numerator, distribute this up here. When you multiply it by the first term, what does that become? Cosine x times sine of y. Multiply it here. And then multiply it to this term. Multiply it to that one, and what does it become? So from the original problem, we got it in terms of sine and cosine, and now we don't have at least the double-decker fractions. This looks a little bit better. Now I'm looking over to the left. It looked overwhelming, and I can see it now. Looking on the left-hand side, look at this denominator. What would I need to do to this to make those two denominators the same? What is this supposed to be from the left-hand side? Isn't it supposed to be 1? So what if we divided, normally we multiply, what if we divided, what would I want to divide this by so it becomes 1?
Cosine y times cosine x.
If I do it in the denominator, I need to do it in the numerator. Right? And how did I know to do that? Because I'm looking over here. This is supposed to be a 1. So what is this divided by that? 1. Minus, what is sine x sine of y divided by cosine x cosine y? That denominator looks good, doesn't it? Let's go to the numerator. What is cosine x times sine of y divided by cosine x cosine y? So what is this divided by this? This divided by that. Isn't it tan y? Plus, and then cosine y sine of x divided by this. This divided by this. To Delia's question, should I change the order? It's not exactly the same. Probably be a good idea if you didn't. It wouldn't be the end of the world, but hard problem to end with. Great way to finish off math class for the day. We have a few more to go over tomorrow. You'll have some time in class to work on 5.2 homework.